Okay, now we're going to continue working with exponents, but we're going to talk about the definition of a zero exponent. If you've noticed so far, we've only been working with positive exponents, so now we're going to be talking about some negative exponents. So still, this is Module 5, and we're in your textbook, in your ebook, section 5.3, and we're talking about definitions of an exponent of 0, so I would say b to the 0, and say b to a negative integer, negative exponent, okay? So let's first define, anytime you have some base raised to the 0th power, that equals 1. Right, so any number to the 0 power is going to equal 1. Right? So for example, 7 to the 0 equals 1. Negative 7 to the 0 also equals 1. Right? Y to the 0 equals 1. Now, I'm going to introduce a little bit of a twist though. Let's say I have negative 5 to the 0, right? That equals 1. But if I have negative 5 to the 0 without the parentheses, that equals negative 1. So again, remember how we did this before? We said if it's not in the parentheses, it doesn't get included. So this is like saying negative 1 times 5 to the 0th power, right? Which is negative 1 times 1, which equals negative 1. So we have to keep in mind, if I don't see the parentheses, there's no parentheses indicating, that exponent only goes with the base. Okay, so notice the difference between this one and that one, right? So notice the difference. Again, I could have negative 2x to the 0. This means that the entire thing inside the parentheses is raised to the 0th power, and anything raised to the 0th power is 1, right? But let's say I don't have that. I only have negative 2x to the 0 power like this. Now, where does that exponent, who does that exponent belong to, right? That exponent only belongs to the x, right? So that's the same as negative 2, and then x to the 0 is just 1. Negative 2 times 1 gives me negative 2. Okay, let's talk a little bit about negative exponents. Okay, so the second part is negative exponents. Right, so we have, say, now the definition of b to the negative n. Okay, so that's, if I have a negative exponent, what I can do is I can bring that down to the denominator and make it a positive exponent, right? So if I have a negative exponent, and I don't have a denominator, right? It's assumed to be 1. I basically bring my exponent and my base down to the denominator and make it positive. Right? So what this, it implies that taking the reciprocal of the base and change the sign of the exponent. Okay, and let me just show you the pattern behind this, how this works. Let's just do an example with numbers that we're familiar with, right? So let's look at this pattern. We know 3 to the 3 is what? 27, right? Let's do 3 squared is 9, right? 3 to the 1 is just 3. And we said 3 to the 0 is 1, right? So what are we doing? Well, every time we're reducing our exponent, right, we're dividing by 3. 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. 3 divided by 3 gives me 1. So now we continue on in this pattern. So remember, now I've gone 3, 2, 1, 0. Let's go to negative 1. Well, if I divide 1 by 3, I get 1/3. Right? If I go one more, if I divide 1/3 by 3, I get 1/9. Right? And remember, 1/3 is the same as 1 over 3 to the 1. Right? 9 is 3 squared. That's the same as 1 over 3 squared. So if you look at this, I had a negative exponent here, and it goes down in the denominator as a positive exponent. So continuing on again, we have 3 to the negative 3 is going to be 1 over 27, which is 1 over 3 to the 3rd. So that's the pattern of how you can evaluate negative exponents. Okay, so let's practice a couple examples. All right, so as an example, we'll say simplify p to the negative 4. Okay, so I'm going to think to myself, p to the negative 4, it doesn't have a denominator, so I'm just going to put that over 1, right? So in that case, remember what I said, if it's a negative exponent in the numerator, I simply bring it down to the denominator, and it becomes a positive exponent. Right? Simplify z to the negative 13th. Well, again, I think over 1, so I bring that down, and I get z to the positive, 1 over z to the positive 13th. Right? Simplify 4 to the negative 2. That's the same as 1 over 4 to the positive 2, or 1 over 16. What if I say simplify negative 5 to the negative 2? Right. Well, that doesn't have a denominator, so I'm going to say that's just like 1. So I'm going to bring that down. The whole thing goes down, right, because it's in parentheses, so it becomes negative 5 to the positive 2. I only change the sign of the exponent, not of my base. Of exponent only, not the base, right? And negative 5 times negative 5 is a positive number, which is 25. Right? So it just becomes 1 over 25. Now if I ask you to simplify negative 5 to the negative 3, again, I look at my exponent as negative, right? So I bring that down, the whole thing, but I make it a positive 3. right? The negative 5 still stays negative. And that's going to be negative 5 times negative 5 times negative 5, right, which is 1 over 125, but the whole thing is negative. Let's try another one. Simplify. 3m to the negative 2. Okay, so if I look at this again, remember if I don't have any parentheses, my exponent belongs only to the base in front of it. It doesn't belong to that 3, right? So that's like saying, right, I think to myself, 3m to the negative 2 all over 1, right? But since it's only the m that has the negative exponent, that goes down into the denominator and becomes positive. The 3 stays on top. The m comes down along with its exponent that changes sign, and I have 3m to the positive 2. Okay. And notice the difference here. Simplify. If I have 3m all to the negative 2, now the whole thing belongs to that exponent, right? So then I can think of it as over 1. So I have 1 over 3m to the positive 2, right? So then I have to use my power rule. So this has an exponent of 1, so it's 3 squared m squared in the denominator, and that just becomes 1 over 9m squared.